Negotiating numeracy.
Creating a scatter plot or line graph. Once we have decided a line graph is the best way to represent our data, we then need to create our graph. There are two ways we can do this, either drawing it by hand with pencil and paper or using a spreadsheet. When drawing by hand, we should use a sharp pencil and a ruler. The first thing to do is to draw and label the axes. Remember, the independent variable goes on the x-axis and the dependent variable goes on the y-axis. Both datasets will be numeric. If they are not, then a line graph is not the appropriate choice of graph. Therefore, we need to ensure we also include the units to show what each variable is measured in. Next, we need to determine an appropriate scale for each axis. The scale needs to include the highest value in our dataset and should normally start at 0. The scale should spread out along the whole axis, making sure to use even increments and increase by an even amount, like this, not like this. This should be done on both axes, using the data for that variable to inform the scale to use. Now we have our two axes drawn, we can start to plot our data. Each data point should have an x and a y value, often represented in a table. Read the x value and find this along the x-axis, and then read the y value and find this along the y-axis. Find the point where these intersect and mark with a cross. A cross provides a much clearer data point than a dot. Continue to plot all the remaining data points to create the scatter plot. Once we have created our scatter plot, we now need to decide if we want to create a line graph by joining the crosses together with straight lines like this, or if we should use a line of best fit, like this. To decide this, we need to think about the purpose of our graph. A line graph is useful for showing precise patterns, while a line of best fit is good for looking at general trends. A line of best fit, or trend line, is a straight line that best represents the data on a scatter plot. This line may pass through some of the points, none of the points, or all of the points. A good line of best fit should have an equal number of points above and below the line. This can be done by estimating a line that best shows the trend of the data. However, a line of best fit drawn by observation is likely to differ from person to person and may not be accurate. Another simple technique which can be used to increase accuracy is to group the data points into 3 clusters. Then mark the middle point horizontally and the middle point vertically for each cluster. This produces 3 points to work with. Now, using a ruler, line up the first and the last point. Then move the ruler 1/3 the distance towards the middle point, keeping the ruler parallel. It is important to note, if we look at the data, sometimes we know that it needs to go through 0, 0. For example, if we were graphing the motion of a car that was starting at rest, then we know that it has travelled 0 distance at 0 time. Therefore, the distance time graph must pass through the point 0, 0. This will not always be the case. For example, perhaps we are measuring the height of a plant, and the plant might start 10 centimeters tall at time 0. It is worth noting that sometimes a curve of best fit will work best for the given data, but the same principle applies. Finally, we need to give our graph an informative title or figure caption. This should give enough information for the viewer to know exactly what the graph is showing. Remember, whether a line graph is drawn by hand or created digitally, it must have clearly labelled axes with units, an appropriate scale on the x and the y axes, a meaningful and informative title or a figure caption, clearly plotted data points, and an appropriate trend line or line of best fit.